Okay, so in this video I just want to talk about the differentiation test that we did. The first question here was, it's worth 10 marks, and part A says that f of x is equal to 3 minus 4x minus 5x squared. And you're asked to differentiate this from first principles. Now, one common mistake a lot of people did was, they tried to change all their signs and actually got the derivative of plus 5x squared plus 4x minus 3. But you can't do that because technically what you're doing there is you're multiplying by minus 1. If you multiply everything on the right by minus 1, you'd also have to multiply the left by minus 1. And then you're left with minus f of x, which doesn't make sense. So if this had been equal to 0, then yeah, no bother, you could just change all your signs, but it's not equal to 0, it's equal to f of x. So you have to go with the signs you've been given. The second step is you get f of x plus h. In other words, everywhere there's an x, you just sub in an x plus h and you simplify it down. Then you want to subtract f of x. To subtract f of x, it's minus 3 plus 4x plus 5x squared. It's just this line with different signs. The 3's cancel, the 4x's cancel, and the 5x squareds cancel, and I'm left with f of x plus h minus f of x is minus 4h minus 10hx minus 5h squared. Now, the next thing I need to do is get f of x plus h minus f of x divided by h. In other words, just divide each one of these terms by h. This will become a minus 4, this becomes minus 10x, this becomes minus 5h. The very last thing you need to do is get the limit as h approaches 0 of f of x plus h minus f of x over h, and you're left with minus 4 minus 10x, and that's your final answer. Now, another common mistake a lot of people did here was they subbed in 0 for h. You cannot sub in 0 for h. If you sub in 0 for h, you'll lose 3 marks. Because I'm not saying that h is equal to 0, I'm saying that h is approaching 0. In other words, it's so small that I can basically treat it as if it's a 0. But it's not actually a 0. It's just really small. So you can't actually sub in h is equal to 0. You just have to treat the question as you have to treat it as if h is 0, but you can't sub that in. Your final answer there was this line here. In part B here, we were told that f of x is equal to x times x plus b to be squared. And we're told that f dash x, the derivative of f of x, is equal to 0 when x is equal to 2. Now, the first thing you should do here is multiply this out. So get the function as a cubic, because obviously in this form it's more awkward to deal with. I think one student managed to get this question right by differentiating this from the product rule. It is possible to just get the derivative straight away by using the product rule, but it's far harder. This question is much easier if we multiply out our f of x first. As well, I'm also told that b is an element of z. In other words, b is a number, it's a constant. So x is my variable, but I can treat b as if it's a 5. Treat b the same way as you would treat a number 5. So the first thing I should do here is multiply x plus b by x plus b. So the x here I'm just leaving as it is, but if you multiply that bracket out, you'll get x squared plus 2bx plus b squared. So to get the function in its simplest form, I just multiply it out. X by x squared is x cubed, x by 2bx is plus 2bx squared, x by b squared is plus b squared x. So that's f of x. Now I can worry about this piece of information. The first derivative is equal to 0 when x is equal to 2. So obviously the first thing we should do here is find the first derivative. Find f dash x. The derivative of x cubed is 3x squared. The derivative of 2bx squared, well, the 2 comes in front, so it becomes 4b times x to the power of 1. And this is the one that caught a lot of people out. A lot of people thought they could bring the 2 in front here and it would become a 2b. But the b squared is a number. If b was 5, then b squared is 25. The derivative of 25x is just 25, so the derivative of b squared x is just b squared. If you think about what's happening there, it's x to the power of 1, so the 1 comes in front, and then it decreases by a power of 1, so it's b squared times x to the power of 0. So my first derivative there was that. Now I'm told I know that this equals 0 when x equals 2. So if I sub in 2, that means the whole thing will be equal to 0. So on the next line, instead of 3x squared, I can just write it as 3 times 2 to be squared plus 4b times 2 plus b squared. And I know that when I've subbed in my 2, the whole thing equals 0. 3 times 2 squared is 12 plus 8b plus b squared equals 0. So all of a sudden now I have a b squared, I have a b, and I have a number. So I have a quadratic equation, and I can find the two values for b. If we just rearrange this as b squared plus 8b plus 12, it's easier to deal with. So I'm looking for the factors of 12 that add up to 8. Clearly the ones I want to use here are going to be 2 and 6. So it's b plus 2 times b plus 6. If I solve this now, they're my two factors, but obviously I need to find the roots. So I can say that b plus 2 equals 0, which means b equals minus 2. And I can also say that b plus 6 is equal to 0, which means b is equal to minus 6. So my two answers there are b equals minus 6 and b equals minus 2. There was 15 marks going for that in the exam. The second part of this question now had 4 parts, and each was worth 10 marks. In the first question, we were told that an open top box is going to be manufactured from a sheet of cardboard. The sheet of cardboard originally was 18 centimeters, so the distance from here to here is 18, and the distance from here to here we're told is 12. But if they're going to manufacture an open top box, they need to cut out these corners so they can fold up the flaps. So each of these flaps is going to be x in height, which means that the distance now from here to here is 18 minus x, so it's 18 minus 2x. The distance here is going to be the whole thing 12 minus x, which is 12 minus 2x. So the length is 18 minus 2x, the width is 12 minus 2x, and the height is x. We're asked to prove the volume is equal to that. So you should start this question off by saying that the volume of a rectangular box is length multiplied by width multiplied by height. Or you could say length by breadth by height, or it doesn't matter, the 3 dimensions, whatever you call them, that's the volume, you just multiply them all by each other. In other words, the volume of this box is x times 18 minus 2x times 12 minus 2x. So obviously we can't multiply them all out at once, so probably the first thing you should do is multiply 18 minus 2x by 12 minus 2x. So if I just leave the x outside, if you multiply this by this, you'll get 4x squared minus 60x plus 216. Now I've multiplied the length by the width, but to get the volume now I need to multiply by the height. And the height of this box is x, so x by 4x is 4x cubed, x by this is minus 60x squared, x by this is 216x. I think for the most part that was very well answered. So the final answer there, the volume of the box, is this. But make sure you should have started off by writing out the actual formula. And that formula is not in your log tables, that's one you have to know. In part B, we're asked to find the value of ore corrected 2 decimal places that will give the maximum volume of the box. Now the word maximum needs to be jumping out at you here. You should recognize that in the previous part, this should be a v. In the previous part, we were given a cubic, x cubed, x squared, and an x. A cubic is, the shape of it, if I was to graph it, is something like that. And I'm looking for the maximum volume. In other words, I'm looking for the maximum. What is the value of x at the max point? So this is just a fancy way of asking you to get the maximum point. So in this case, if my v is equal to that, the first thing I want to do to get the max point is get dv dx, because dv dx represents the slope. If I get the derivative here, 3 comes in front, so it's 12x squared minus 120x plus 216. So the derivative of this is just 12x squared minus 120x plus 216. In other words, that's the slope. To identify where the turning point lies on this graph, or where the max point is, I need to let the slope equal to 0. Or in other words, I need to let this equal to 0. So I can say 0 is equal to 12x squared minus 120x plus 216. Now it says to leave your answer to 2 decimal places, so that's a hint that you need to use the minus b formula to solve this. Now you could have divided everything by 12 here and then used your minus b formula, which is fine, but I think for the most part, most people actually just did it straight away. So in this example, I'm going to use the minus b formula using these figures. So if I use this quadratic, a in this case is 12, b is minus 120, and c is 216. I'm letting the first derivative equal to 0, in other words, identifying where the slope of the curve is equal to 0. So it said 2 decimal places, so I use my minus b formula. Your values should have worked out as 2.35 and 7.65. Now I need to figure out which is the maximum and which is the minimum, because it only asked me to find the maximum. In order to identify which is the max or which is the min, you need to get the second derivative. So I know the first derivative is this, 12x squared minus 120x plus 216, which means the second derivative, which I can call d squared y, actually sorry, I was using functions. So I can call it f dash dash x. The second derivative, you bring your 2 in front, it's 24x. And this is x to the power of 1, so you can bring your 1 in front, it's minus 120. So your second derivative here is 24x minus 120. In order to identify which is the max and which is the min, you sub in the x values. So if I sub in the x value of 2.35, I'm going to get 24 times 2.35 minus 120. And if you plug all that into your calculator, you're going to get minus 63.6. So now I can make my conclusion. So to conclude this, you should say that, right, in this case, the second derivative is less than 0. Because clearly minus 63.6 is less than 0. If when you sub in the x value, the second derivative is less than 0, you can conclude that x equals 2.35 is at the max point. Okay, so that means, so when you sub in the second derivative, if it works out negative, that means it's the max point. So it's at the max point. I can't actually say that it is the max point because notice there we haven't actually found the point. We've only found the x value. We also need to find, in order to find the point, we need to find the y value. But in this case, they didn't actually ask you to find the y value, just the x value. Most people did well and they got 7 out of 10 here, but a lot of you forgot to get your second derivative. So to prove it's a max, you get your second derivative, sub it in, and it'll be negative. If you were asked to prove it was a minimum, like for example, if you subbed in this one, if you subbed it into the second derivative, it would be positive, it would be greater than 0, which means that it's a minimum point. Okay, there was also 10 marks for question 2 part C, and for a lot of you, this is the thing that caught you out. Because you were still thinking in terms of differentiation, this is nothing to do with differentiation, and nothing to do with the maximum or the minimum point from part B. We're just told that the company chose a value for x. And we're told that x is a natural number. So they told you that x is an element of n. Remember, an element of n just means a natural number. It's a whole positive number. And we're asked what are the values of x that they could have chosen. So just basically, what are the values of x that are possible? Now when you've answered part D, I'm going to talk to you about this again because if you answer part D and you found your roots, you could just read it straight off the graph. But you didn't even need to find the roots. You could have just read it straight off the diagram. You just need to look there and see what are the possible values of x. So for example there, x equals 10 is impossible. Because if x was 10, then this would be 18 minus 20, that would be negative. This would be 12 minus 20, that would be negative. So basically in this question, I'm literally just looking for the values of x for which these 3 dimensions are positive numbers. Notice you can't have a dimension of 0. I can't have x equals 0, or I can't end up with that being 0. So if you look at that diagram, first of all, x can't be 0. The first one definitely needs to be a 1. The first natural number is 1. There's nothing wrong with x being equal to 1. I can't use 6 because if I use 6, then this would be 12 minus 12, so that would be a 0. So the biggest number I could use is 5. So there's actually 3 different ways that you could have written this out. You could have said that x needs to be greater than or equal to 1 and less than or equal to 5. If x is in that range, then all 3 of these dimensions are possible. And in that scenario, you have to mention x is an element of n as well. Another way you could have written that is that x needs to be greater than 0 but less than 6, and x is an element of n. That's the same dimensions there. It needs to be less than 6, in other words 5. It needs to be greater than 0, in other words 1. They also accepted you can write it as 1, 2, 3, 4, 5. So the set of values were 1, 2, 3, 4, 5. So any of those would have given you the 10 marks in that question. Okay, so for part D, we were asked to draw a sketch of the curve indicating the roots and indicating the turning points. So I'm going to first of all talk to you about the roots. In order to find the roots, remember to find the roots, that's the pointer across the x-axis, that means y equals 0. So in other words, you could just let your function equal to 0. Now, probably what went through most people's head was you can do trial and error to get the first root and then do long division to get the other 2 roots. However, it's far, far easier because there's no number at the end, because there's only an x cubed, an x squared, and an x, it's far easier than that. In order to get the easiest way to get the roots here was you can just factorize out what's common. In other words, I can factorize out 4x, and I'm left with x squared minus 15x plus 54. Okay? So straight away, I know the first thing here is equal to 0. I know the second thing is equal to 0. So I can get my first root straight away and say that one of my roots is 0. 4x equals 0, which means x is equal to 0. To get the other root, I just need to factorize this. X squared minus 15x plus 54 equals 0. So I want the numbers that multiply to give me 54 and add to give me 15. So it's x minus 9 and x minus 6 equals 0. So to solve that, my other two roots are x equals 9 and x equals 6. So the three roots of this cubic are 0, 6, and 9, or in other words, the coordinate 0, 0, the coordinate 9, 0, and the coordinate 6, 0. Now, in part B of the question, we've already identified that a turning point exists when x is 2.35 and a turning point exists when x is 7.65. So in order to find the corresponding y values, all I need to do here is sub these x values into my original function. So if I just want to know what is the value of y when x is 2.35. So I literally just sub it in and I'll get my coordinates. So if I just sub in x equals 2.35, I get a corresponding y value of 228. So my max point is this. If I sub in x equals, when I sub in x equals 7.65, I get a corresponding y value of minus 68, so my min point is this. Now that I have my roots and I have my max point, my min point, I can draw a pretty accurate sketch of my curve. Okay, so once I have my coordinates 0, 0, 6, 0, and 9, 0 as my three roots, my max point 2.35, 228, my min point 7.65 minus 68, I can sketch my curve. And it said to indicate clearly the roots and the turning points, so you should indicate clearly these values. Now, another way of answering part C would have been if you just came up with this graph. In this scenario, the y value in this question represents the volume. Okay, so obviously if the company wants to make a box, they can't make a box that has a negative volume. That just doesn't make sense. They need to make a box that has a positive volume. In other words, it needs to be in this section. So this section, the volume of the box is positive. This is possible. So the x values in this scenario are 1, 2, 3, 4, and 5. Now I suppose you could look at this and say, well, it's positive over here as well. But I think you would have noticed that if x is 9, clearly all of the dimensions in the box would have been either the 18 minus 2x would have been 0, the 12 minus 2x would have been negative. So that one just doesn't fly. But in this case, this part of the curve represents when the volume could exist, when the box could exist. So the values for part C would have been 1, 2, 3, 4, and 5. Now I hope this video made sense. If you're unsure on anything there or you want me to clarify something, then just let me know in class during the week and I'll try and explain it differently.